Morning. Now we are discussing the Unit 2 Automobiles Unit 2 Engine Auxiliary Systems. Now we are discussing the electronically controlled injection system for SI engines. In electronic controlled gasoline injection system for SI engine, fuel supply and timing are controlled by electronic means. Electronic fuel injection has developed with the development of solid-state electronic devices such as diodes and transistors. Recent days, these systems are commonly used as they function quickly and they respond automatically to the change in manifold air pressure, engine speed, crankshaft angle, and many other secondary factors. The systems are developed by Robert Bosch Corporations. This consists of following four units. First one, fuel injection system, air injection system, and the sensors, electronic control systems, ECU. Then now, there are two type of, is classed into, there are two basic gasoline injection systems. One is the multi-point injection systems. Another one is the monopoint injection systems. Multi-point fuel injection system, it is called port injection systems. In this system, there is an injection valve for each engine cylinder to supply or spray fuel in the cylinder induct manifold space as in manifold space. So each injection valve is placed in the induct port near the induct valve. The main advantages for this system is that allow more time for mixing of air and petrols. Then second one, monopoint or single point fuel injection systems. This systems is also called throttle body injections. In this system, an injection valve is positioned slightly above each throat of the throttle body. Injection valve spray fuel into the air just before it passes through the throttle valve and the air enter the induct manifold. This method simplifies the construction of the engine block. Also, it does not obstruct hot spot near the walls, affecting cooling water jacket size at the place. Moreover, it required only one circuit on the computer to control injection, which simplifies the construction of electronic control unit. Thus, it reduces the cost of systems. Then, electronic control gasoline injection systems, there are four factors. First one, fuel delivery system, air injection systems, sensor and flow control system, electronic control unit. First one, that is the fuel delivery systems. The reason for using gasoline fuel injection is to control the air fuel ratio of the engine more precisely. This system consists of an electronic driven fuel pump which draw the fuel from fuel tank through filter and forces it into the pressure lines. At the end of the pressure line, the fuel pressure regulator is placed. Fuel system regulator is placed. The fuel pressure regulator is connected to the induct manifold. The pressure difference between fuel pressure and the manifold pressure is kept constant by this regulator so that the quantity of fuel injected is dependent only on the injection open times. In this Bosch L-type system, fuel metering is controlled by engine speed and measuring the induct manifold. The second one, air induct or induction systems. In these systems, the incoming air from atmosphere flow initially through air filter and through the fuel sensor. This air flow sensor measures the amount of air flow in the manifold of generator voltage signals, which is dependent on the amount of air flow. The air flow meters consist of rectangular plate. which is turns in a rectangular shaped channel to the defined the angular position dependent on the pressure from flowing air. It returns to original position during normal condition by using a spiral coil springs. Then third one, sensor and airflow control systems. Third one, sensor and airflow control systems. The sensors used in electronic gasoline injection systems are first one, airflow sensor, then induct air temperature sensor, exhaust gas accessions, manifold absolute pressure, speed or crankshaft sensor, engine temperature sensor, crankshaft position sensors. First one, airflow sensor. The sensor sense electronic control unit ECU how much of air is being drawn into the induct manifold for adjusting the quantity of fuels. And second one, induct air temperature sensor. This sensor measures the temperature of induct air for the timing the mixer strength. The next one, exhaust gas adjustance sensor. A sensor located in the exhaust system which provides ECU about the amount of oxygen in exhaust gases. From this ECU can determine if the airflow ratio is correct. The manifold absolute pressure sensor is a sense the vacuum pressure in the engine's inlet manifold and it gives on induction of the load to the engines. Then speed or crankshaft sensor. It provides the information to ECU about the engine rotating speed and the position of the crankshaft. The engine temperature sensor. This sensor senses the temperature of coolant in the engines. Coolant temperature is used to determine if more fuel is needed when the engine is cooled or warming up. Then last one, crankshaft position sensor. ECU needed to know how fast the engine spinning where the crankshaft is in its rotations. ECU fires the spark and injector at the right times. Knocking sensors. The knock sensor is a microphone type sensor that detects the sound of knocking so that ignition time can be deterred. A cold stop valve is fitted just behind the injector valve to inject the additional fuel for cold start. This valve has especially good atmospheric characteristics. The operation of cold start valve is controlled by a thermotime switch sensor to ensure cold start up to minus 33 degrees centigrade. The extra fuel is needed by ordinary starting and warm-up period is also supplied by this valve. After cold start, the additional air required with richer air fuel mixer is supplied by an ordinary air valve during idling conditions, which bypasses the throttle valve. It is the additional idling speed. The opening of air valve varies as a function of engine temperature. The next one, that is the electronic control unit. It is the heart of the fuel injection systems. It consists of computer which takes information from sensor and control the amount of fuel injected by operating the injector for just the right amount of time. The unit contains a number of printed circuit board on where sense of transistors, diodes, and other electronic components are mounted. It makes the visual to the analysis circuit respond to various input signals. The data measured in the form of signals by various sensors such as manifold, the pressure, engine speed, crank angle, oxygen in exhaust, etc., are transmitted to the electronic control unit. This unit computes the air-fuel ratio required for the best performance of the engine during each engine cycle, and it sends signal to the injection valve and the part of the systems. The amount of fuel injected is varied by varying the injector operating time, and the ECU cannot be adjusted or serviced. Then advantages of electronic control systems. There is the very highly quality of fuel distribution is uptime. Therefore, high compression ratio can be adopted without any danger of uh, redundancies occurring. It increases the volumetric efficiencies. The manifold in the injection system carries only air. It is reduce the specific fuel consumption due to better distribution of mixer to each cylinder. It is free from blowback and icing. Exhaust emission are less due to precise air fuel ratio according to the engine requirement. Better starting and acceleration are ensured that than a carburetor systems. So what is the disadvantage? The initial cost is very high because of precious and complicated components with the electronic circuit. It is the major disadvantages. More complicated mechanism because of electric system, injection nozzle and fuel injection pump. Increase the service problem occurs. More noise is generated. Weight and space requirement are more than a conventional carburetors. Thank you.